Ed Ansett, i3 Solutions Group. Essentially, there's a number of problems with today's infrastructure. First of all, it's massively over-provisioned. If you look at utilization rates, actual utilization rates across a broad portfolio of data center service providers and even end users, the utilization is relatively low. It's typically, it can be very, as low as 30% and perhaps sometimes up to 70% in the case of hyperscale, but in general, in aggregate, the utilization is probably around about 30 to 40%. So that's one thing. The other thing is the infrastructure itself is rigid. So once you've acquired a power system, you choose the topology that you want, the configuration that you want, and you have it essentially forever until you take it out. That could be 10, 20 years. Now the thing is, the typical tenure from an IT perspective is perhaps 3 years. And we're looking at IT refresh rate, perhaps a couple of years, every 3 years. As we know, technology, IT changes quite rapidly, but we're stuck with the same infrastructure. So the ability to be able to change the power system infrastructure without having to remove it by preempting what type of redundancy levels may or may not be required. In other words, building in flexibility is highly desirable, and that's something that ARP can achieve. The way we think these type of problems can be solved, or one way in which this can be solved, is to deploy a system which can manage the reliability configuration, or if you like, the redundancy configuration of the power system in the data center. That is to say, move away from the traditional autonomous power system where the system basically operates in a standalone mode and will act when there's a fault. We'll recover from typically a single fault. We need to be able to deal with that power system in a more intelligent way, so that we can manage it under certain fault scenarios to enable a flexible, if you like, a multi-redundancy level infrastructure to be provided and manage all the various failure scenarios that may go along with that type of installation. The main benefits that ARP provides are the flexibility to make use of this wasted power, this low utilization, to be able to provision that under very specific circumstances. So that is a key thing, because over provisioning in data centers is a very significant issue. It also allows us to provide the flexibility, so we don't have this one-size-fits-all that we've currently got. That's today's data centers, single topology, whatever the topology is, and it's fixed. We don't have to have that anymore, and we can change the topology as the IT requirements change, the service level requirements change from an IT perspective, so the power system can change to match the IT service level requirements. And then finally, another thing that this system is capable of doing is load prioritization, so that it can essentially react to save critical loads at the cost of less critical loads. It's something that we call IT load prioritization. Yeah. The situation currently in data centers is that when we have a failure, for whatever reason, we typically design for one failure, but the reality is failures often occur simultaneously. So there's an event and often secondary event. When that happens, very often the system's unable to respond to that, and in other words, unable to handle a second or a tertiary failure. So another thing that IT load prioritization gives us is the ability to save the more critical loads. It's a little bit like, if you think of it from a medical perspective, perhaps having a very serious infection in your leg, and rather than amputating from the knee down, basically killing off the patient, because that's currently what will happen in a data center. If we lose sufficient component capacity, the data center itself will fail altogether, as opposed to saving the most critical parts. So that's another thing that ARP can do. So the next steps in terms of the development of this concept is working with industry partners to develop the necessary firmware modifications we need in the first instance to certain components, and then once that's done, then the next step will be to build an initial prototype, and then following that to build out a full-fledged model. So one of the things that people are keen to understand is whether ARP is contingent on the use of static transfer switches or STS. STS is one way in which we can deploy ARP, certainly from a co-location point of view or a wholesale data center service provider point of view. That would be the right way to go. Another way you can do it, of course, is to manage the IT load power sources directly. In other words, by having an interaction between the IT load power inputs or the power cords and ARP. So, but that's more of an end user defined configuration, whereas using static transfer switches is more predisposed to wholesale service providers, co-location service providers, because they can deploy that infrastructure initially in anticipation of their end user customer needs. I guess in a word, the surprise, a lot of encouragement from people. I think a lot of people are sort of skeptical. It's perceived by some as adding an additional layer of complexity, and there's no getting away from that. But the reality is that if the system is deployed properly, as any system, it will ultimately be able to provide cost benefits, flexibility benefits, and in real terms, eventually, reliability benefits that we currently don't have today, even with that additional supervisory layer sitting above the power system, the ARP supervisory layer. I think the event is, from our perspective, an ideal venue and forum for us to present this kind of idea, because we have a good mix of people that will be interested, will be able to provide some kind of feedback, positive and negative. There will be people, end users, there will be manufacturers that will be looking at this thinking, well, what does that mean for us? Is that going to impact the way in which we write our software? So I think it's the right place. I can think of very few other type of venues where we have the same ubiquitous impact as this venue. Data Center Incident Reporting Network, just a quick update on that. DCERN, as we now call it, because it's obviously easier to say. That's going pretty well. It's really starting to gain momentum. We had our second meeting here yesterday with the exec and with the TAC, the Technical Advisory Council, and it's really moving along nicely. We've still got to address a number of questions regarding getting people's confidence that this is secure reporting, because obviously one of the big barriers to DCERN's success is people believing that when they report an incident, whatever their intentions are, as well-meaning as their intentions may be, that information may well be confidential, and how we ensure that the confidentiality aspect is addressed. That aside, really very good. I was very happy. John Lane, myself, Peter Gross, and Simon Allen, we all sort of addressed various issues at the meeting yesterday, and I think we all walked away thinking, yes, that was good. We've moved this along in the way that we hoped that we would. So we'll have to see how it goes, but it's quite encouraging.